Hello YouTube, my name is Tarun, and from today onwards we will be building a new playlist where we will be displaying the tools used in technology. Our first tool will be Wireshark. It's a very famous protocol analyzer. You can use the same tool to capture live packets or to open pre-captured traces. Basically, this tool can capture any live packets from the accessible interfaces. Drop down menus, you can refresh the interfaces. From the list of menu, you can see that the same tool can be used for multiple protocols, whether they are being used in telephony or IT. From the list of interfaces, you can see 3 interfaces which are capturing traffic. 2 are Ethernet cards and 1 is loopback card. So to reconfirm the IP addresses, I open the command prompt in administrator mode, and from the ipconfig command I can see that there are 2 interfaces. There is one interface from my Oracle VM VirtualBox and the another interface is from my router that is carrying the gateway 192.168.1.1. So basically I'll be capturing traffic on this 1.37. Start this test. I captured the value of ARP table. From that I can see that there is no value present for 192.168.1.5. Selected the interface and I started capturing the packets. On the other hand, I opened command prompt and start doing ping to IP 192.168.1.5. The IP was reachable, and from the next command I can see that the entry has been made in the ARP table and the MAC address against the same has been updated. On the background, Wireshark was capturing traffic, so I stopped it. And from the list down menu I can see that multiple protocols have been captured. To capture a specific packet, I put a filter of IP address of the particular IP 1.5, and from there I saw that ICMP, that is the ping packets, were captured there. This was not displaying all sort of packets related to 1.5. But here on the ICMP protocol you can see on layer 2 that the destination MAC address has been updated, same like which was updated in the command prompt. To check all the traces, I basically cleared the values from the filter menu. There I was able to see that almost 264 packets were captured. Another method to search for a particular packet is to click on the search icon. Then from the packet details, you can search for a particular string that is carrying the string value which you are looking for. Here I search for 192.168.1.5. So all the packets were displayed there. Packet was the ARP, and you can see that it has been broadcasted to MAC address FF, which means it has been broadcasted to the all hosts available over the network. And on the layer of ARP protocol you can see that it is not carrying targeted MAC address. This scenario is same like a classroom where a teacher is calling of the name of the particular student, and in the classroom every student is listening, but the particular student replies and the teacher updates the status like where the student is sitting. So among all the hosts available over the network, and in the next packet the MAC address has been updated. This all traffic has been traveling over ARP protocol, that is address resolution protocol. and the next packets were ICMP protocol, which showed ping between the interface and the 1.5 IP. You can check and list down parameters traveling on layer 2 and layer 3. You can list out specified packets from the IP address as a source or destination, and you can export them. In the export menu, you can see that 264 packets have been captured in total, and out of those you have filtered out 6 packets. So you can specify a number of packets or the counts, and you can save them in a pcap trace. The sole purpose of this action is to minimize the size of the trace. So post saving this trace, from the drop down menu, either we can open a new session or we can open the recently saved pcap traces. Just for the sort of new experiment, we continued without saving and tried to capture new packets on the interface while the WhatsApp desktop app are running in the background. Earlier we saw that only ICMP, ARP and TCP packets were being captured. So we will see, like in case of any app, what sort of data will be carried over the interfaces. So we started capturing these packets and tried to open the WhatsApp desktop app in the background. So while the app is being started, we see there has been lot of data traveling over the interface. So ultimately we had to stop capturing the data so that we can analyze the captured packets. So almost 3366 packets were captured in between, and this trace was displaying lot of protocol packets which were captured. So while doing a sorting over the protocols, we saw ARP, DNS request, HTTP request. On the DNS query, packet number 334, you can see that there has been one standard query been made on the DNS query from the router IP to the DNS server, that what is the canonical name for web.whatsapp.com, and this query has been reverted in the packet number 335. So on packet 335 you can see that the query has been reverted with the canonical name and the IP which is carrying, which will be hosting a web.whatsapp service for us. So we saw that in very short span of time a lot of packets have been captured in the trace. In this short span of time it is not possible to display each and every protocol packet, so I thought to move on the important section of the trace. To have a more clear picture, then using our search icon, we did a search on a string value of WhatsApp, and there we saw that on the transport layer security there has been server keys exchange made with the cipher key agreement. Post that, encrypted handshake were made between the client and the server. So in the coming section of videos on Wireshark, we will be showing you from where you can get sample authenticated traces so that you can have a clear picture on the protocol analysis. Do like, share and subscribe us so that we can make more videos on such contents. Thank you so much for watching this video.